Today's topic is variation or gradation in the properties of elements while moving from left to right in a horizontal row or the period of a modern periodic table. Now, before we come to this, we should know about certain properties, that is metallic character, non-metallic character, electron affinity and electronegativity. So dear students, metallic character is the tendency of an element to lose electrons and form positive ions. Okay. Non-metallic character is the property of an element to gain electron and form negative ion. Now, what is showing these properties? Atom of a particular element. Like, why we say metallic character? Because lithium, sodium, potassium are metals and their atoms, they easily lose electrons and form positive ions. Then non-metallic character, carbon, sulfur, phosphorus, oxygen, their atoms have a tendency to gain electrons and form negative ions. And all this is done due to the reason that they want to attain noble gas configuration. So metallic character is tendency of an atom to lose electron, form positive ion. Non-metallic character, tendency of an atom to gain electron, form negative ion. Electron affinity is the amount of energy released when a neutral gaseous atom gains an electron and forms a negative ion. Okay. And electronegativity is the tendency of an atom, of an element, to attract the shared pair of electron towards itself. And what is basic nature of oxides? That whether the given oxide, when dissolved in water, turn blue litmus red or red litmus blue. Okay. So, like oxides of metals, sodium, potassium, they are basic in nature, but oxides of carbon like CO2, sulfur dioxide, they are acidic in nature. Yes, there are certain oxides which are neutral. Okay. So, by knowing these properties, now we have to study how do these show gradation while moving from top to bottom in a group and left to right in a period of periodic table. So in this video I am talking only about periods and they will be separate for groups. Now I have drawn here period second of the modern periodic table. It is very clear. You see atomic numbers are increasing by 1. So you have to note down in your copies, while moving from left to right in a period, in a modern periodic table, atomic number goes on increasing by 1. Okay. So lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10. Right. So it is increasing by 1. Now when we write the electronic configuration, we see 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8. Now here is, something very interesting to note down and understand, that although while moving from left to right in a period, atomic number is increasing by 1, new electron is being added from lithium to beryllium, then beryllium to boron, but no new shells are being added, right? So, lithium, beryllium, starting from lithium up to neon, the number of shells remains the same, and that is 2. Okay? So, children, you can see that here is a lithium atom with 1 nucleus and 2 shells, right, with 2 electrons and then 1 electron. Okay. Now we come to beryllium and we see there is a nucleus now with 4 protons. Here 3 protons. here 4 protons, right? Here 3 electrons and here 4 electrons. But the shells remain same. So students, many a times when I ask the question to the students that what will happen to the size, they mostly say size will remain same because they look here that the number of shells is same. But you see, this is lithium, then beryllium, and then there is boron, again nucleus, shell 1, shell 2. Four electrons and 5 electrons. Now you can see that what has happened is that the size I have shown is decreasing. Now the question comes why? The question why is answered like this, that while moving from left to right in a period, no new shells are being added. Nuclear charge is increasing by 1. I repeat, nuclear charge increases by 1. No new shells are added. So, the pull, that is the effective nuclear charge, increases. Nuclear charge is also increasing. Along with increase in nuclear charge, effective nuclear charge is also increasing. So, due to this, the nuclear force, which is a weak force, attractive force, is increasing. Hence, the electrons which are there in the valence shell are squeezed close to the nucleus. Hence, the size decreases. Okay, students? So, now you have to keep only four lines in your mind and you can answer any of these questions. First line, moving left to right, nuclear charge increasing by 1 because atomic number increasing by 1. No new shells are added, so effective nuclear charge is also increasing. Hence, number of valence electrons increases. Atomic size decreases due to increase in effective nuclear charge and nuclear pull. Now, metallic character was the tendency to lose electrons, right? But now the effective nuclear charge, the positive force which is pulling the electron, has increased. So, the tendency to lose electron decreases. Tendency to gain electrons increases because electron is negative and the positive force has increased. So, non-metallic character increases. Similarly, the energy released during this also increases, and electronegativity, that is the tendency of the nucleus of an atom to attract shared pair of electron towards itself in a covalent bond, also increases. But basic nature of its oxides decreases, and all this is due to only and only one concept, that effective nuclear charge increases while moving from left to right in a period. So, my dear students, if you are given a question like this, that which is more metallic, so you will say lithium as compared to oxygen. And if I ask you which is more metallic, lithium or beryllium, then there will be lithium. It means when you are on the left hand side of the periodic table, you will find metallic elements are on left hand side. Okay. So, now I told you that while moving from left to right in a period, the atomic size decreases. My dear students, please keep one fact in your mind, that this is valid only and only till group 17. Inert gases are not showing this characteristic. Okay? It means Neon is not going to be the smallest atom in the second period. Similarly, we have neon, argon, krypton, radon. So, it is not that the group 18 element will be the smallest. It is the group 17, but exceptions are always there. I hope you have understood this topic. Thank you so much.